Welcome back, and I've got a fascinating experiment to show you today. What we're going to look at is the strange properties of coils of wire and what in physics we call inductance. So if I want to light up a light bulb, I know the easy thing to do is just to connect it directly to a power supply. So I'm going to connect to the DC of this power supply, and I'll do it through a switch. You'll see why in a minute. And back to the power supply. Very simple. And light the lamp like that. So on goes the power supply and on goes the lamp. No problem at all. But what happens if I wire this light bulb through much longer wires? And it's that I want to do today. So let's now wire the light bulb up on a much longer reel of cable. Now you might say, why would I want to do that? Well, imagine I bought a reel of cable and I was going to use it for different experiments, some of them over short distances and some over long distances. I wouldn't want to cut up the wire into lots of pieces. I'd like to keep it intact on its drum and just unwind it when I need a really long piece of cable. So what I've got here is a coil of wire, lots and lots of turns, and to make it even longer I've got a second one here. Now I know this looks terribly complicated, but the two reels of wire, the two coils here, are sitting on a big iron block. That helps this experiment work. So what we're going to do is we'll come out of the power supply, into the first reel, out of that one, into the next one, and back to the switch. So what we've got now is our light bulb wired up to the power supply, but now the electricity is going to go through much longer lengths of wire. But the important thing is that wire is all coiled up. So let's turn on and see what happens, and I think you'll be surprised. Right, so let's turn on, and I really do think you'll be surprised by what you see here. So listen for the switch and watch the light bulb. 3, 2, 1. So, I don't know if you noticed what happened there, I'll repeat it, but it's very strange. If you look at the light, it seems to come on a bit late. So, I wonder if you've got an explanation for this. Well, let's go for the first one, and I'm going to tell you now it's wrong. Okay, a lot of people might think because the wire is much longer here, I haven't actually measured it, I could work it out, but it's many meters longer, then it takes much longer for the electricity to get down the wires and whatever. No, that's not true at all. The electrons indeed move very slowly, but if one electron pushes the next and pushes the next, that process of one electron moving the next one is a very rapid process indeed. Which is why when you turn on a desk lamp or something like that, it doesn't matter if you're on an extension lead. As long as it doesn't have a light bulb that needs some time to warm up, it comes on instantly. But with this apparatus, I turn on and there is a delay. So we need another explanation for this. So the explanation here is not an easy one, so bear with me. And I won't go on for too long with too much detail. What we've got here are inductors, and inductors are very interesting objects in physics. They're basically wire wound around a metal core. And if you want a high inductance, you want more turns, you want them to be a bigger cross-sectional area, and you want some soft iron in the middle. Now, what you make when you pass electricity through an inductor is an electromagnet. But what's interesting about this type of electromagnet is it's not magnetic when it's turned off. It's fully magnetic when it's turned on. But it's that time when you first turn on the current to the lighting that's interesting. So we turn it on. Current rushes into these turns of wire and makes this object magnetic. But that magnetism causes the electrons rushing into the wire to not rush in quite as rapidly. This is the process of inductance. In other words, the changing magnetic field in these coils opposes the current rushing in. So it kind of slows down the rate of change of current. So instead of the current being on and the light lighting rapidly, the current tries to go on rapidly, but it fails and it comes up slowly, opposed by the changing magnetic field in these. But once the system's on completely, it's DC, the current is constant, there is no changing magnetic field to oppose the current coming in, so the current becomes a static value and the light bulb lights. So what you're seeing in that delay is you're seeing the current trying to rush in and light the lamp immediately, but failing to do so because the magnetic field forming in here opposes that current rushing into the system. So I hope you enjoyed that very brief look at inductance. It's quite a complicated topic, but I hope you've made a start to understanding it. Anyway, I'll be making another video soon, and I look forward to seeing you then.